Hi folks, we're going to take a look at number 9 on page 217. So let's see what's going on here. So we have somebody flying their kite at the end of a 40-meter string. String makes an angle at the ground of pi over 4, and then something happens and this string is making an angle of pi over 3 with the ground. And they want us to determine the expression for the horizontal distance that it moves and the vertical position that it moves. And then part C asked about approximating those. You can just stick those in your calculators and check them. All right, so let's draw ourselves a diagram. So let's say this is the ground. Okay, and let's start with the first thing that we have. So we have this 40-meter string at an angle of pi over 4. Okay, so there's the kite. And then let's see if I got another color here. We've got the kite moves, so a bigger angle of pi over 3. Okay. So now the angle here is pi over 3. And of course, what doesn't change is the length of the string. That's still 40 meters. Okay, so we want to determine the change in the horizontal position and then the change in the vertical position. So we start to realize here that we can solve this just like a regular trigonometry problem back from grade 10. The only difference is we're working with angles given in radians. Okay, so what we can do is break this down into a right angle triangle. So we'll call this, horizontal distance 1, or I guess this should be horizontal distance 2, since that's the second position, and this will be the vertical distance 2. And then we do the same thing with the other version here. So this we'll call horizontal distance 1, and this will be vertical distance 1. Okay, and so essentially if we want to solve part A, we just have to find the difference between these two horizontal differences. That'll tell us the change in horizontal distance, and then similarly here, we're just going to subtract to find the difference in the vertical distance. All right, so what I have to do in A is I have to determine I'll use the larger one minus the smaller one. So I'm going to have to determine H1 minus H2. Okay, and in the second one, we're going to be determining V2 minus V1. Okay, so to help us out, let's sort of set up these triangles here. So if I want to find, say, for this first one, if I want to find H1, okay, well, I'm working with the pi over 4 triangle. Okay, so what do we have? We have a hypotenuse of 40, and I want to find the horizontal distance 1, and eventually I'm also going to want to find the vertical distance 1, so I might as well work on them at the same time with pi over 4. And then similarly, I'm going to do the same thing with the pi over 3 triangle here. So again, this is pi over 3. This is still going to be 40, and I'm still looking now for H2 and V2. All right, so I think if we do one of them, we can see the way the rest of these are going to go here. So if I'm looking for H1, well, clearly I'm going to use cosine. So I have cosine of pi over 4 is just equal to H1 over 40. So just applying my trig ratio here. So H1 is just going to be 40 times cosine of pi over 4. But of course, we know that cosine of pi over 4, special angle 1 root 2, is just equal to 1 over root 2. So this is going to be 40 over root 2. Okay. Now, I might as well find V1 while I'm at it. So V1, now I'm not going to do all the work because I see exactly what's going to happen. The only difference here is it's going to be 40 times sine of pi over 4, which of course sine of pi over 4 is also 1 over root 2. So this will be 40 over root 2. Okay, and it's going to be the exact same thing here. If I'm looking for H2, okay, it's 40 times, again, because I'm looking for this adjacent side, it's just going to be cos of pi over 3. Okay, now I'm not going to write it out, but imagine the pi over 3 triangle is 1, 2, root 3. So if it's cosine, it's going to be 1 over 2. So 40 times 1/2. So that's going to be a nice number, 20. And then for V2, it's just going to be the same thing except with sine of pi over 3. Okay, and sine of pi over 3 is just going to be root 3 over 2. So this is going to be 40 root 3 over 2, which of course we can simplify to 20 root 3. All right. So now it's just a matter of inputting these things into the expressions we need. So if it's h1 minus h2, well, h1 is 40 over root 2 minus, this is just going to be 20, okay? So let's subtract these, okay? You shouldn't leave them as two separate expressions. At the very least, you should bring it into one single fraction. So common denominator is going to be root 2, so this is already in that denominator, so 40 minus, we need the root 2 here, so 20 root 2. Okay, and this would be an acceptable answer since I'm not asking you to necessarily rationalize these denominators, but say we wanted to continue, okay, we would just multiply numerator and denominator by root 2. So if we multiply the numerator by root 2, remember you have to multiply both terms, so it'll be 40 root 2 minus 2 times, 20 times, well, root 2 times root 2 is just 2, all over root 2 times root 2 is 2. And so here we end up with, we can distribute this division by 2 to both of these. So this will be 20 root 2 minus, and those will cancel out, so minus 20. And there you have it. So this is the distance in, the change in the horizontal distances. So we should specify that this is in meters, okay? And now we're going to do the same thing with the vertical distances. So in B, this time here, it's V2 that's larger than V1, so I'm going to do V2 minus V1. And V2 was 20 root 3 minus 40 over root 2. Okay, so this is a good question for practicing your skills with radicals. So again, I'm going to take a common denominator of root 2. So here, what do we have? This is going to be root 3 times root 2 is root 6, so 20 root 6 minus 40. And so this would be an acceptable answer if you weren't rationalizing, but just for the fun of it, let's rationalize here. So I'll multiply numerator and denominator by root 2. So this is going to be 20 times root 6 times root 2 is root 12 minus 40 root 2 over, well, root 2 times root 2 is 2. So we can simplify this by, again, distributing our division here. So this will be 10 root 12 minus 20 root 2. And we can even go a little further because we know that root 12 can be written as root 4 times root 3. So square root of 4 is 2. So this would be 20 root 3 minus 20 root 2. Okay, so like I said, some good practice with our radicals here. But in the end, in terms of our recap, essentially, you just have to see that this is a regular old grade 10 trigonometry problem where you're working with two right-angled triangles. The only difference is that because we're working with these special angles, okay, we were able to do this whole problem without ever having to access our calculator. All right, so that's it for this one.